Okay, our first type of fat or lipid is called a triglyceride. So get this going here. A triglyceride. All right, so this is a form of fat. And in fact, triglycerides, this is kind of what we would think of as dietary fat, the fat that we eat, like bacon grease, like butter, like olive oil, like canola oil. All those fats, those are triglyceride molecules. So let's look at how these molecules are put together, what they're made of. If you're going to build a triglyceride, you need two components. The first thing is this molecule here, and this molecule is called glycerol. So I'll write this over here. Glycerol is kind of what we call the backbone for a triglyceride. And glycerol, you're going to recognize it because it has 1, 2, 3 carbons. It's always 3 carbons in a chain. And each carbon has a hydroxyl group attached to it. So there's 3 OHs. This is why learning those functional groups is so important, so that when I say hydroxyl group, you know what I mean. So glycerol, it's going to be 3 carbons in a row and then an OH on each carbon. And this is the first component that we need to build a triglyceride. It's the backbone of the molecule. The next thing we're going to need to build a triglyceride is something called a fatty acid. And this molecule outlined in yellow here, this is one fatty acid. I know it's a strange name, a fatty acid. So to recognize a fatty acid, they also are pretty distinctive. They have a long carbon and hydrogen chain. Like you see the carbons, and all the carbons have all these H's. So all there are here is tons of C's and H's in a long chain. And then at the very end, you have a carboxyl group. C double bond O, OH. That's a mess, but let me erase it. You can see a carboxyl group right here. Every fatty acid is going to have that. So it's going to be a long chain with just C's and H's, and then a carboxyl group on one end. That is what we call a fatty acid. All right, so we have glycerol, which is our backbone, and we have fatty acids, which are these long chainy molecules with a carboxyl group. Now, to make a triglyceride, we're going to have to hook these together. So I'm going to bring my fatty acid up to my glycerol backbone, and I'm going to do a chemical reaction here, which should look familiar to you guys. Now, admittedly, you've never seen glycerol before, and you've never seen a fatty acid before. So those individual molecules are new, but the reaction that they're doing should be very familiar. What we've got here is they come close together, and when these interact, there's an H and an H and an O, 2 H's and an O. These can interact together, do a chemical reaction, and join up to make 2 H's and an O, H2O, which is our friend water. And when we do that, if we take these two H's and O's away and put them together to make water, then this O can hook directly to this C. All right, so we have hooked 2 molecules together and extracted water. This should look very familiar to the reaction that we used when we built disaccharides and polysaccharides, right? This is condensation synthesis, right? Building a molecule by pulling out water. I know here it says dehydration synthesis. Some textbooks call it dehydration synthesis. Some textbooks call it condensation synthesis. It's the same thing. I hate that they use different words. Can you see that? Condensation synthesis. Same thing, all right? So, although the molecule isn't following that monomer-polymer pattern particularly, we are still using condensation synthesis to hook the parts together. Now, we've done that once. We put 1 fatty acid here, but to make a triglyceride, I'm going to get 2 more fatty acids. I'm going to hook one on here to this OH and another one here. Remember, each fatty acid has a carboxyl group, so it's going to have an OH, and there's another OH here. So every time I hook a fatty acid on, I can pull out 2 H's and an O and hook the molecules together. So you'll end up with a fatty acid hooked here, and a fatty acid hooked here, and a fatty acid hooked here, and I will have pulled out 1, 2, 3 water molecules for each hooking on, and then I'll end up with this giant thing down here. Now, another way to think about this is that glycerol is the backbone, and it has 3 docking stations, 3 OH groups. and I can dock one fatty acid here, click, and when I dock it on, water gets pulled out. I can dock another one on here, and I can dock the third one on here. And when you've done that, you create this molecule down here, which is the triglyceride. So the tri makes sense now. Tri means 3, and you can see there's 3 tails on this backbone. So one or two other things. Oh yeah, so a couple things that always confuse students. So this on its own is called glycerol. Let me erase all this. This on its own is glycerol. This on its own is a fatty acid. It's not called a triglyceride until you hook the whole shebang together and you get this giant molecule down here. So only this one is the triglyceride, the bottom one. The other thing is there are many different kinds of fatty acids, and how they differ is in the length of this chain. And sometimes you can get double bonds in this chain too. And so fatty acids can be as short as 6 or 7 C's in a row. Some can be as long as 20. Now this triglyceride on this slide, all the fatty acids are the same. This one, this one, this one, they're identical, which is fine. Some fats are like that, but some fats have different fatty acids on each one. So this one might be long, this one might be short, and this one might be medium length. They don't all have to be the same. And the combination of what fatty acid tails are hooked on, that is what causes differences between fats. It's why olive oil is a certain way, canola oil is a certain way, butter is a certain way, lard is another way. They're all triglycerides, but their tails, the different tails that are hanging off the backbone are different, and that's what gives each triglyceride or fat its unique characteristics. All right, so that is triglycerides, one of the kinds of lipids.